I will do this one. See ma. So determine, this is the question given ma, pure resistive circuit. What is meant by pure resistive circuit? In this circuit, only resistance is present. That is the meaning of this one, no? Okay ma? So instantaneous values of voltage and current are given. Then peak power and average power he is asking us to find out. So you take that equation, E is equals to 250 sine 314t. What is the general equation of voltage ma? E naught sine 314t. That's all, no? What is E naught value? Huh? What is meant by E naught? Maximum value of EMF is E naught. Already we discussed, no? Similarly, current is also given, no? I is equals to 10 sine 314t. Write the general equation. I naught sine 314t. Clear, ma? So, maximum value of voltage is 250. Maximum value of current is 10. So, what is meant by peak power? Peak power means maximum power. Power formula, voltage multiplied by current only, no ma? So if you take a peak voltage and a peak current, you will get peak power. Ante kada? That's it. So therefore E naught value is how much? 250. I naught value is 10. So 2500 watts. That is my peak power, maximum power. Now second question is also he is asking. What is second question? Average power. Okay ma? Average power can be written as average value of EMF multiplied by average value of current. Okay? Average values are they given? It's not a? ఇవ్వలేదు మరి ఎలా చేస్తారు? వచ్చేసినట్టు. ఓకే, యావరేజ్ వాల్యూ చెప్పండి. Sima, E average, how we have written, what is the formula, do you remember? So 2 by pi times of E naught. That's all. No? Similarly, I average 2 by pi times of I naught. That's all. No? I naught values already we have. No? Just substitute them. So therefore, P average, how can I write? It is 2 by pi times of E naught multiplied by 2 by pi times of I naught. Okay, ma? So 2 by pi whole square multiplied by E naught into I naught. And E naught, I naught, they are maximum values. So therefore average power can be written as 2 by pi whole square multiplied by E naught value 250. I naught value is how much, ma? 10. So just do this calculation. That will be the average power consumed. Are you able to understand? Okay. See, so see here. Calculate the resistance and peak current in a 1000 watts hair dryer connected to 120 volts and 60 hertz supply. So what happens if it is connected to 240 volts line? So it is designed to operate at 120 ma. But if I connect to 240, what happens? Second question. What is the first question? We are supposed to find out resistance also. We are supposed to find out peak value of current also. Peak value means what? Maximum value of current. Okay, now see. So what is the power given? Power is 1000 watts. So when you see this one, what do you understand? Is this average power? Is this peak power? Or is it RMS power? Which power? How can you say? How can you say it is RMS power? Sima, everything will be always represented in terms of RMS values only. This is the point which you should understand. See, and on machines also, on this fan it will be written 220 volts. So 220 volts is not average, 220 volts is not maximum, it is only RMS. Every value mentioned will be always in terms of RMS. That is the first point which you should understand. So note point is that every indicated value is in terms of RMS only. Okay? So therefore, PRMS is how much? 1000. And here, voltage supplied is how much? 120 volts. Now this is peak, or this is average, or is this RMS? This is also RMS only. Okay, if it is average or if it is peak, he will say that. Edi cheppaledu ante, if he did not mention anything, it is RMS value. Clear? Now therefore, by using power and voltage, I can calculate current, because P is equals to V into I. This is the formula, no? So therefore, I is equals to P by V. Power is how much? 1000. Voltage is how much? 120. So if you do the calculation, how much I will get? 8.33. 8.33 amperes. And now can you say what is this current? This is also RMS current only. Okay? But he is not asking RMS current, what he is asking? Peak current. How can you calculate? Peak current, how can you calculate? Cheppandi. IRMS is equals to 0.707 times of I naught. Already we have studied, no? Or you can write I naught divided by root 2. So therefore, I naught value only he is asking. I naught is equals to how much? Root 2 times of IRMS. So I naught is equals to root 2 times of IRMS is how much? 8.33. So do this calculation. That will be my peak value of current. So answer is 11.8 amperes. 11.8 amperes. Are you able to understand? Okay. First question. Next he is asking resistance also. How can I calculate resistance? Now see. Now resistance he is asking, So you can use I is equal to V by R, or you can write power is equal to V square by R. This is also a formula, no? So therefore, resistance is equals to V square divided by P. Okay, ma? What is the supply potential, ma? 120. 120 whole square. What is the RMS value of power? 1000. Do this calculation, you will get resistance of this circuit. So 14.4 ohms. 14.4 ohms. That is the resistance of the circuit. Are you able to understand? Now what is the next question he is asking, ma? What happens if it is connected to 240 volts line? So connected to 240 volts line. Okay. So if it is connected to 240 volts line, what is the power consumed? Power is equals to V square by R. Resistance never changes, no? Okay, ma? Resistance is always a constant. Only voltage changes, power changes. So what is the supply voltage we are taking? 240. So 240 whole square. Resistance just now we have calculated, 14.4. So if you do this calculation, what is the power consumed? It will be approximately 4000 watts. 4000 watts. Okay, ma? It is designed for how much wattage? 1000. But it is consuming 4000. So what happens? It will melt. Heat produced will be very large. In heating effects we have studied, no? Heat produced will be very large, and this hair dryer will melt. That's it. Okay, right now. So therefore what we write? Therefore, hair dryer will be destroyed. Hair dryer will be destroyed. That's it. Okay, ma? So calculate the frequency at which inductive reactance of 0.7 H inductor is 220. Okay, ma? Frequency he is asking us to find out. Inductive reactance XL is equals to 220 ohms. And L value is how much? 0.7. So all these terms, they are present in this equation only, XL is equals to 2 pi FL. Okay. From this I want to frequency. So frequency is equals to XL divided by 2 pi L. XL 220, 2 pi multiplied by L. L value is 0.7. All the units are in SI system only, so no problem. So just do this calculation, that is my required frequency. So the frequency which you should get is 50 Hertz. That's it. See this question. So question is, how much inductance should be connected to 220 volts 50 Hertz supply? 220 volts means what ma? ERMS. Already I said, always we write values in terms of RMS values only. Clear? So RMS value is 220, 200 and frequency is 50 Hertz. Okay? And what is the maximum amount of current which is flowing? Maximum amount of current means, now this is not ERMS, no? This is I0 value. I0 value is 0.9. Are you able to understand? Clear? Voltage is given in RMS values, current is given in maximum value. Okay? So he is asking us to find out L value. So where I find L, we know that XL is equals to 2 pi FL, no? From this I can get L value. Okay? Frequency is there, I want to find out L value. XL is not there. And what is XL? What is XL? XL is inductive reactance. Inductive reactance. Or you can say just resistance of inductor. You should not say like this. For your understanding, I am saying resistance of inductor. Are you able to understand, ma? So if I know XL value, I can calculate L value also. XL, how can I calculate? By Ohm's law, I can find out, I is equal to V by R. I is equal to V by R. So what is R? R is equal to V by I. So therefore, XL is equals to, either I can write ERMS divided by IRMS, or I can write E0 divided by I0. So both the methods I can use. Are you able to understand? See, resistance is voltage by current. So XL is ERMS divided by IRMS, or you can divide maximum value of voltage divided by maximum value of current. But you should not marry a donkey and a horse. ERMS divided by I0, this you should not write. Idi gaadide, idi gurram annamata. Pelli chesina pedda labham ledhu. Arthamavutundi kada? This you should not do. Either two horses or either two donkeys. Both should be of the same species. Are you able to understand? So therefore what I do, either you convert I0 into IRMS, or you convert ERMS into E0 and divide both of them. Then you will get the answer. Okay? Now ERMS is given, no? So what is the relation? We know that ERMS is equals to E0 divided by root 2. This already we have studied, no? And I0 is already given. So what I will do, so E0 value is equals to root 2 multiplied by ERMS. That's all, no? So therefore how can I write root 2 multiplied by ERMS divided by I0. I can write like this. Understood, no? E0 is what? E0 is root 2 times of ERMS. And ERMS value already given. And I0 is also given. So just do this calculation. So therefore it will be how much? So root 2 times of ERMS is 200 and I0 value is 0.9. Okay, ma? So from this I can get XL value. Once you get XL value, you can calculate L value also. What is L value? L is equals to XL divided by 2 pi F. So XL is this much. So root 2 into 200 divided by 0.9 multiplied by 2 pi multiplied by frequency. Frequency is 50. Clear, ma? So if you do this total calculation, that is my answer. So answer should be approximately 1 Henry. 1 Henry. That is my answer. Approximate answer. Clear? Okay. So this is the question. 318 microfarad capacitor. So capacitance is how much? 318 into 10 power minus 6. Micro means 10 power minus 6. Clear, ma? So it is connected to, what is the supply voltage? 230, frequency is 50 hertz supply. Then we are supposed to calculate capacitive reactance. What is meant by capacitive reactance? XC. XC formula? 1 by 2 pi FC. So just substitute in these values. So 2 pi into, what is the frequency given? 50. Capacitance is 318 into 10 power minus 6. Clear, ma? So if you do this calculation, we will get capacitance. And capacitance how much? We will get 10 ohms. Okay? That is the capacitance. So, next question. What is the next question he is asking? RMS value of current. Okay? IRMS. Can you say how can I calculate? I naught by? I naught evadu ichina trade? Power konteji? I is equal to V by R. ఇది కూడా ఒక మెథడ్ ఉంది. ఇది కూడా యూజ్ చేయొచ్చు కదా, మరి వాడండి. సో I is equals to, voltage is already given nama, 230, and resistance is nothing but resistance of capacitor, no? 10 ohms. తెలివితేటలు. So 23 amperes of current will flow in the circuit. That's it. Are you able to understand? So we have calculated IRMS also. Now he is asking equations of voltage and current. Clear? So voltage equation, how can I write? Okay. E is equals to E naught sine omega t. This is the equation of voltage, no? Clear? E naught value, is it given? It's not ivaleda. Then what can I do? ERMS is given, no? ERMS is how much? ERMS is equals to E naught divided by root 2. This equation we know, no? So therefore what is E naught value? E naught value is equals to root 2 times of ERMS. So therefore E naught is equals to root 2 times of ERMS is 230. Okay, ma? Sima, already I said you that any information which is given, it is always in terms of RMS values only. Okay, this you should remember. So therefore substitute in the equation. So E is equals to E naught. Instead of E naught, or I will write like this, E naught sine. Instead of omega, I can write 2 pi f, no? 2 pi f into t. Omega I can write like this, no? So therefore E is equals to E naught value, root 2 into 230 sine. Clear, ma? So 2 pi, what is the frequency? Frequency is 50 multiplied by t. So again, if I want to simplify this one, 230 root 2 sine. Okay. So pi value is 3.14. 3.14 into 100 is 314. So 314 t. So this is the equation of voltage. Are you able to understand? Now, can you say how can you write equation of current, ma? Current equation. Current equation. What is the equation of current, can you say? I is equals to I naught sine omega t. వారి మిమ్మల్ని తగలే, ఇది ఏ సర్క్యూట్ రా ఇది? This is what kind of circuit? Capacitive circuit. In capacitive circuit, which one leads current? Or which one leads and which one lags? Current leads voltage, no? So therefore, what is the equation I have to write? I naught sine omega t plus pi by 2. This is what we have to write, no? Because already we studied that in capacitive circuit, current leads voltage by 90 degrees. Okay, ma? Now just substitute all the values. So I naught value, is it given? I naught value is not given, just we have RMS value. Okay? And we know this relation, IRMS is equals to I naught divided by root 2. So therefore I naught value is how much? Root 2 into IRMS. Okay? So root 2 into IRMS is how much? 23. So I is equals to 23 root 2 sine. Okay, ma? Omega t value already we have calculated. 314 t plus pi by 2. So this is the equation of current. That's it. Understood? Very easy. Okay, see ma'am. So 50 microfarads capacitor, capacitance is how much ma? 50 into 10 power minus 6 farads. This is the capacitance of the capacitor. So 230 volts. What is meant by 230 volts? RMS value, no? So ERMS is equals to 230 volts. Clear ma? So determine maximum charge on the capacitor. So maximum charge. We know that charge stored on the capacitor, what is the formula? Charge stored, we know that C is equals to Q by V, no ma? So therefore Q is equals to C into V naught. I can write like this. Now can you say what is meant by V naught here? Maximum? So this is the maximum potential difference between the plates of a capacitor. Are you able to understand ma? But maximum value of potential difference, is it given? RMS value is given. So how can I convert this one into maximum value? Root 2 times of ERMS. Already we have studied, no? So this can also be written as Q naught. Q naught is maximum amount of charge, is equals to capacitance multiplied by E naught. I can write maximum value of potential difference. Are you able to understand me? So therefore Q naught is equals to capacitance is how much? 50 into 10 power minus 6 multiplied by E naught. How can I write? Root 2 times of 230. I can write like this, no? In the brackets, if you want, you write down. So since ERMS or E naught is equals to root 2 times of ERMS. Okay, ma? So calculate this value. This is the amount of maximum charge stored on the plates of a capacitor. And the answer of this one is 16.26 into 10 power minus 3. 16.26 into 10 power minus 3 coulombs. That much amount of charge will be stored maximum. Okay. So next question. What is the next question? He is asking maximum energy stored in the capacitor. So can you say this one? How can I calculate? Formula for energy stored. Capacitance में पढ़ी है मामूल से पढ़े तो ज़्यादा तेरी చదవని చాప్టర్ గురించి చెప్తే ఇంకేం గుర్తుంటుంది వరకు చెప్పండి ఫార్ములా ఫర్ ఎనర్జీ స్టోర్ See, my energy stored is equals to half CV square. గుర్తుందా ఫార్ములా ఇది? There are many formulae for energy stored in between the plates of a capacitor. Half QV, Q square by 2C. So these are the different formulas. So capacitance I know already, and maximum value of potential also I know. Already we have calculated. And charge stored also we have calculated. Capacitance we know. So any formula you can use. Anyone I will use this formula. Clear? Anyone you can use, no problem. So therefore, and he is asking maximum energy. Now can you say what is meant by maximum energy? This is the equations for energy stored. Maximum energy means? Support. Value should be maximum. So therefore half, what is the maximum value of capacitance? I pi. It is a fixed value. Capacitance maximum minimum undadu anamata. So capacitance is how much? 50 into 10 power minus 6 multiplied by, now maximum value of voltage, E naught. E naught value already we have calculated, no? So how much it is? Root 2 times of ERMS. Clear, no? So therefore maximum energy stored is nothing but half into 50 into 10 power minus 6 multiplied by root 2 multiplied by ERMS value is 230. Okay, ma? So do this calculation. That is my maximum energy stored. And the answer is 265 joules. CV square. Root 2 into 230 whole square. Okay? That's it. Nahi, dekho. See, ma'am. So a coil having resistance of 7 ohms. So resistance is how much? 7 ohms. Inductance is how much? 31.8 millihenry. Milli means 10 power minus 3 Henry. Okay, ma? So it means that this is what kind of circuit? This is an RL circuit. Clear, no, ma? This is an RL circuit. So let us revise this RL circuit once again. Okay. So if this is RL circuit and if this is the alternating source of voltage which we are giving, which is equals to E is equals to E0 sin omega t. Clear, no, ma? Then this is resistance and this is inductance. Then do you remember what is the phasor diagram we have drawn, ma? So this is VR, voltage drop in resistor. This is IRMS, the current flowing in the circuit. And this is VR, voltage drop across the inductor. This is what we have drawn. And what is the supply voltage? This becomes my supply voltage. ERMS becomes the supply voltage. Okay. And this angle pi, this is called as phase angle. This angle pi is called as phase angle. Now from the same diagram, I can also draw impedance diagram also. Impedance diagram, how can I draw? That also we have drawn, no? So this is resistance. So R value I will write here. Here we have resistance of inductor. So XL value I will write here. And combined resistance is called as Z impedance, that we will write here. Are you able to understand? And this angle is called as the phase angle. This is what we have written. See, according to the information given, you have to identify what kind of circuit is given in the question. Then accordingly you have to do the problem. Clear? Now see what is the first question he is asking. Circuit current. Okay, ma? Circuit current. Circuit current, how can I calculate? 230 volts is already given, no? ERMS value is how much? 230. That is already given. Now, I value I can calculate. I is equals to V by R, Ohm's law. Or I can write ERMS divided by Z. I can write like this also. No? This is RL circuit, no, ma? You have to take the impedance of both. You have to take the resistance also and you have to take the capacitive reactance also. Both you should take. So Z value, how we have calculated, do you remember? Z is equals to square root of R square plus XL square. This is how we have written. So first you are supposed to calculate this one. So Z is equals to square root of R is 7 square. XL value is 2 pi into F into L whole square. This is XL value, no? So therefore Z is equals to square root of 7 square plus 2 pi multiplied by frequency is 50 and inductance is 31.8 multiplied by 10 power minus 3 whole square. Okay, ba? So if you do this total calculation, then I will get Z value. Okay. Now let us see what is the Z value. So once I get Z value, I can calculate current also. So IRMS, how can I calculate? IRMS is nothing but ERMS divided by Z. So do this calculation, that is the circuit current. Okay. So what is the Z value we got? Z value is 12.2 ohms, ma. Z value is 12.2 ohms and I value will be how much? 18.85. 18.85 amperes. Okay. So this is the answer for my first question. Now see the second question. Phase angle. Phase angle means what? Phase angle means angle pi. This is called phase angle. You can take cos pi, sin pi, tan pi, anything you can take according to your convenience. Okay. See, here opposite side is given, adjacent side is given. I take tan pi, no? Tan pi. Take tan pi. Tan pi is equals to XL divided by R. XL already we have calculated. Where is XL? XL we have not calculated. Directly we have calculated, no? So, R by Z. You can take, no problem. Anything you can take. Okay. All the three values we have, no? Any value you can take. You can take sin pi, cos pi, tan pi. Generally we take tan pi. What is the reason? Because generally in the problems XL and R will be given. So that's why I am representing it tan pi. You can take sin pi also, you can take cos pi also. Okay. So tan pi, anything you can take, ma. So XL value, how much we got? XL value, XL. Just a cut. XL is 10. If I do this total calculation, I will get 10. 10 divided by resistance is how much? Resistance is 7. Okay. So this is my tan pi value. So pi is equals to tan inverse of 10 by 7. 10 by 7 greater than 1, no? So definitely angle will be greater than 45 degrees. Because tan 45 is 1, no ma? So angle you will get is 55 degrees. 55. Okay. So what is the phase angle we got? 55 degrees. Now what is the third question he is asking? Power factor. Can you say how can you calculate power factor? Power factor. Chappandi. Cos pi power factor. Malli R by Z cos pi is called as power factor. Clear nama? Pi value already we have calculated now 55. So cos 55. Cos 55 is called power factor. So cos 55 value 0.573. 0.573. Clear no? Next, power consumed. Power consumed, can you say how can I calculate in RL circuit? IR square into R, that's it. So for power consumed, we can use two formulae now. So either I can use ER, IR, cos pi, or I can use IR square into R. Already we have studied, no? Two formulae we can use. So what is the current flowing? Did we calculate current? 18.85. 18.85 whole square. Resistance is 7. So do this calculation, that is the power consumed. And the answer is 2484 watts. 2484 watts. This is the power consumed by the circuit. Okay? Chemistry bio? Chemistry kadadalati. Jandara. Okay, Sima. So, pure inductance. Inductance value is how much? 318 into 10 power minus 3 Henry. So is connected in series with a pure resistor of 75 ohms. Circuit is supplied from frequency is equal to 50 hertz source ma, and voltage across 75 ohm resistor, that is VR. Voltage across 75 resistance means VR only, no? It is found to be 150 volts. Then what are the values he is asking us to find out? ERMS he is asking us to find out. And similarly, phase angle also he is asking us to find out. Clear now? Now let us see how we can do this calculation. So first one, ERMS. So ERMS, what is the equation of ERMS? This is equals to, in RL circuit already we know the phasor diagrams, no? Clear ma? This is ERMS, this is VR, and this is VL. So therefore ERMS will be how much? This is equals to square root of VR square plus VL square. Okay ma? VR value already we know 150. VL value how can I calculate? VL is equals to I into XL, no? This formula we know. Ohm's law, V is equal to I into R. Okay. What is the RMS value of current? Is it given? Current value, is it given ma? Current value is not given. So what I can do? Resistance and voltage are there, no? From this you can calculate I value. How can I calculate I value? We know that I is equal to V by R. So what is the potential drop across resistor? 150. Resistance is 75. 75 2s are 150, no? So RMS value of current is 2 amperes of current. And XL value how can I calculate? XL is equals to 2 pi FL. So 2 into pi into frequency is 50. And what is L value? L value is 318 into 10 power minus 3. So if you do this calculation, I will get XL. Okay, ma? Let us see what is the value of XL we got. Yeah, question is XL is 100 ohms. 100 ohms. Okay. Now calculate VL value. So VL value is equals to IRMS multiplied by XL. IRMS is 2, XL is 100. So totally 200 volts. So this is the potential drop across the inductor. Are you able to understand? Now ERMS I can find out. No? What is ERMS? Okay, ma? So ERMS is equals to square root of VR square plus VL square. So VR 150 whole square, VL 200 whole square. So do this calculation, you will get ERMS. Okay. So not really. ERMS you will get 250 volts. Okay. So that is the supply voltage which we have to give to this circuit. Are you able to understand, ma? Now what is the next question he is asking? Next question is phase angle. First make a note up to here. Now we are supposed to find out a phase angle also, no, ma? Second question. So can you say how can I calculate phase angle? Impedance diagram I will try to draw. Phase angle. Okay. So what is the impedance diagram? So this is R, this is XL, and this is Z. R value I know, 75. XL value I have calculated. So which trigonometric ratio is better? Tan pi. So tan pi is equals to XL divided by R. XL is 100, resistance is 75. So pi is equals to tan inverse of 100 divided by 75. So 100 by 75 is greater than 1. So definitely angle will be greater than 45. So answer which you will get is 53.06. 53.06. That is the phase angle. Okay? That's it. Okay. Sima. So a capacitor of capacitance 79.5 microfarads is connected in series with non-inductive resistance. So resistance value is 30 ohms and supply voltage is how much? Supply voltage is 100 volts. Frequency is 50 hertz. Okay. So phasor diagram of RC circuit we know, nama. This is RC circuit. And how will be the phasor diagrams? This is VR, voltage drop across resistor. This is IRMS. And this value is VC. So in the case of capacitor, voltage lags current by 90 degrees. No? Voltage drop in capacitor lags supply voltage, supply current by 90 degrees. So therefore this is my supply voltage ERMS. And its value is already given as 100 volts. Clear, ma? Now see. So what is the first value he is asking? Circuit impedance. Z value he is asking. Okay. Z value how can I calculate? Square root of R square plus XC square. XC square. R value is already given. XC value 1 by 2 pi FC. So therefore 1 by 2 pi frequency 50. Okay, ma? Multiplied by capacitance is how much? 79.5 into 10 power minus 6. Okay. So therefore XC value how much we will get? XC value is 40 ohms. Student atla fast ga cheyali. Clear, ma? Next. So circuit impedance, now circuit impedance Z value is equals to square root of R square plus XC square. So Z is equals to square root of R value 30 square plus XC value 40 whole square. Clear, ma? So Z is equals to 9 plus 16. So root 2500, 50 ohms. So this is my capacitance. Total impedance of the circuit. Are you able to understand, ma? Next, phase angle. So phase angle is very easy to calculate, no? XC already I have calculated. R value is already present. So draw the phasor diagram. Impedance diagram here also if I draw, this is XC, this is R, this is Z. Okay, ma? So I have Z also, I have R also, I have XC also. So you can take any parameter, any trigonometric ratio you can take. Clear? విచ్ వన్ షల్ ఐ టేక్? XC అండ్ R. ఈ రెండు చూడడానికి బ్యూటిఫుల్గా ఉన్నాయి, ఈ రెండు తీసుకుందాం. ఎనీథింగ్ యూ కెన్ టేక్ tan pi, ఆపోజిట్ బై అడ్జసెంట్. XC 40, R value 30, 4/3. So tan pi 4/3, then pi value is how much? 53 degrees. That is our answer. Clear number? Completed number this one? Idi. So second one we forgot. Circuit current also he is asking, no? How can I calculate circuit current? Sara. Okay, ma? So circuit current. I is equal to V by R. Impedance did we calculate, ma? We have calculated, and supply voltage is already given, no? So I is equals to 100 divided by impedance is 50. So 2 amperes of current will flow in the circuit. That's it. Clear? Sima. So question is, calculate the capacitance of a capacitor to be connected in series with 100 volts 80 watts lamp. Okay, ma? So that I can use it on a 200 volts 50 hertz supply. That is the question. First we will try to understand what is the meaning of this question, ma. So what is the bulb given? Bulb given is 100 volts 80 watts. This is the bulb. It means it is the rated voltage and rated power of the bulb. Already we have studied rated values, no, ma? What is meant by rated values? उससे कम है तो so they should operate at same voltage and same power. That is the meaning of this one, ma. This is designed to operate at 100 volts. It should operate at 100. It is designed to operate at 80 watts. It must work at 80 watts. But the problem is that we have a supply of 200 volts. The supply which we are getting to our houses, it is 200 volts. But I want to make it operate at 100. So what I can do is, in this circuit, I can connect a capacitor. Okay, ma? If I can connect a capacitor, then what happens is, current gone. ఏమవుతుంది? అది అవుతుంది అన్నమాట. See, ma. So therefore, what we were discussing. So this bulb is designed to operate at 100 volts and 80 watts, ma, and it should operate at same potential. And power consumed also should be same. So potential that this bulb should work, that also should be 100, and the power it should consume also should be 80 only. So therefore, what is the current that should flow to the bulb? That also I can find out, no? Current, how can I calculate, can you say? So let us make some note points. Note point is that this is rated voltage and rated power. Rated voltage and rated power. It is designed to operate. It is designed to operate at same values. Now can you say what is the rated current, ma? Rated current, how can I rated current I can calculate by using the relation P is equal to V into I, no? Because power is there, voltage is there, current I want to calculate. Clear, no? So therefore I value is equals to P by V. Power consumed is 80, voltage is 100. Okay. So therefore current is 0.8 amperes of current. Understood, no? So through this bulb, how much current should pass? Through this bulb, 0.8 amperes of current should pass. If it passes less than 0.8, it will not function properly. If current is greater than 0.8, it will fuse. Now the point is that, but I want to make it to operate at 200 volts. This is the problem, no? Okay, ma? We should make it operate. We should make it operate at bit voltage at 200 volts. Clear, no? So therefore, let us draw the circuit diagram. So consider this is the bulb and this is the capacitor which should be connected in this circuit. Okay? And this is the bulb. Are you able to understand? Now, capacitor is connected in series to this bulb. No? Capacitor is connected in series. Series means what do you understand? Same current should flow through capacitor also. That is the meaning of this one. No? So through the bulb, if 0.8 amperes is flowing, through the capacitor also 0.8 amperes of current should flow. Okay? So therefore, now what I can do, this is bulb nama. Bulb means pure resistor. Sister and resistor. Pure resistor. Bulb is a pure resistor. So it means this is an example of RL circuit connected in series. No? This is what kind of circuit? RL circuit. Bulb is a source of resistor and this is a capacitor. So this is an example of RL circuit. And in RL circuit, RC circuit. So in RC circuit, how can I draw the phasor diagrams? So this is VR, this is IR, and this is VC. This is how I can draw. No? Clear, no? And this will become my ERMS, RMS value of current. Now what is VR? Voltage drop across resistor. What is the voltage drop across resistor? 100. Here resistor is nothing but bulb. No? Resistor ante evaru ikkada? Bulb. So through the bulb should consume only 100 volts only. Supply voltage may be anything. Supply entaina undachu. Adi matram 100 volts consume cheyali. It should consume only 100. So VR value is 100 volts. Clear? And ERMS is how much? 200. Because we are making it to operate at 200. No? So supply voltage is definitely 200. So ERMS is 200. Are you able to understand? So once I calculate 100 volts and 200 volts, I can calculate VC also. No? What is the potential drop across the capacitor? How can I calculate? Can you say? VC, how can I calculate? Minus. 200 minus 100 చేస్తే వచ్చేస్తుంది మరి ఎట్లా? So we know that 200 is equals to square root of 100 square plus VC square. Pythagoras theorem. I can write like this, no? So therefore VC, how can I write? VC is equals to square root of 200 square minus 100 square. Are you able to understand? So this gives my VC value, potential drop across the capacitor. So VC value is 173.2 volts. 173.2 volts. Are you able to understand what is happening? Bulb will operate at 100. Capacitor will operate at 173. Then my supply voltage can be 200. Bulb is operating at 100 only, no problem. But supply voltage is 200. So capacitor should take 173.2 volts. Now it is satisfied. So VC value I have calculated, no? But what he is asking, capacitance he is asking. So capacitance, how can I calculate? First of all, let us calculate XC. See, we know that V is equals to I into R, no? So R value is equals to V by I. R is nothing but XC. XC is equals to V by I. Okay? So XC is equals to V by I. So it is operating at what voltage? 173.2. Current is how much? 0.8. Already we have studied, Nama. Same current should flow through bulb also, same current should flow through capacitor also. So what is the potential drop in capacitor? 173. And what is the current flowing? 0.8. So if you do this one, I will get XC value, a resistance of capacitor or capacitive reactance. Yeah, right problem. So how much it should be? XC is 216.5. 216.5 ohms. Now can you say why I have calculated XC? ఎక్కడి నుంచి వస్తుంది? So XC value is 1 by 2 pi of C, no? From that I can get capacitance. That's it. Very simple. Clear, ma? So therefore once I got XC value, XC is nothing but 1 by 2 pi FC. So therefore capacitance is how much? 1 by 2 pi F multiplied by XC. So 1 by 2 pi, frequency is how much? 50, multiplied by XC value is 216.5. So calculate the capacitance. That is the capacitance which I should connect in series. 14.7 microfarads. Okay, ma? That's all. Very simple calculation. Understood? No? Question is based on which logic? Rated current and rated voltage. Very, very, very important model. Same type of question can be asked in inductance also. In inductance also same method of calculation. Okay? Right. See, let us try to understand this question. So, three impedances are connected in series across a 200 volt 50 hertz supply. So, RMS value of voltage supply is how much? 200. And supply frequency is 50 hertz. So first impedance is a 10 ohm resistor. 10 ohm resistor means it is pure resistance only, no? Clear now? So let us call it as R1. R1 value is 10 ohms. Clear? Next, second is a coil. Coil means what? Inductor. Coil means inductor. Any wire wind in the form of a spring is called as a inductor. Clear ma? So second one is an inductor. Sima. So second one is a coil. Coil of inductive reactance 15 ohms. It means it is XL value, no? XL. It is not XL. Inductive reactance only, no? XL. XL value is how much? 15 volts. And 5 ohms resistance also. It means in the same inductor, some amount of resistance is also present. That can be present. So every inductor can have some resistance also. Every capacitor also can have some resistance, in addition to their inductive reactances and capacitive reactances. Okay, ma? So therefore, in the same inductor, there is some resistance also. And how much it is? It is 5 ohms. Clear, ma? And while the third component consists of 15 ohm resistor in series with 25 ohm capacitor. It means XC value is how much? XC value is 25. Are you able to understand, ma? And in addition to this capacitive reactance, there is some 15 ohm resistor also. It means it is R3 value. And R3 value is how much? 15 ohms. So are you able to understand, ma, what is happening? So this is first impedance. Okay? These two combinedly, they make second impedance. And these two combinedly, they will make third impedance. Are you able to understand? First impedance, second impedance, third impedance. So it means this is what kind of circuit? RLC circuit. That's all, no? Resistor is there, inductor is there, capacitor is also there. So definitely this is RL circuit. This is the circuit. Are you able to understand? Now in RL circuit, we have studied three conditions, no? Can you say what are the three conditions? VL is greater than VC. VL is equal to VC. VC greater than VL. Now out of these three conditions, which one is satisfying here? Can you say? VC greater than VL or VL greater than VC? Which condition is satisfying? Look at the data and try to say the answer. VC greater than VL. How can you say? XC greater, no? Sima. So when VL is equal to VC, what was the information I got? I got XL is equals to XC. This is what I got, no? When potential drop across inductor and potential drop across capacitor, when they are equal, then the resistances also will be equal. But here if I observe carefully, XC is 25 ohms, but XL is 15 ohms only. So it means XC is greater than XL. So what is the given condition? Given condition is XC is greater than XL. So therefore VC should be greater than VL. This is the case given. So identification of cases is also very important. Clear, no? So if VC is greater than VL, this is what kind of circuit? Resistive circuit, inductive circuit, or capacitive circuit? Capacitive circuit. So therefore it is capacitive circuit. Okay. So for capacitive circuit, how can I draw the phasor diagram? Do you remember? Capacitive circuit ki phasor diagram yala. So this is VR, this is IRMS, this is VL, and this one is VC. Do you remember, ma? VC is very large, no, when compared to VL. So therefore, this becomes my ERMS. And this value, they will get cancelled with each other. And what is the remaining value? Remaining value is VC minus VL. This is how we have written. Do you remember? So this is the analysis of the problem. Until now we have understood what is the given problem. Now we will try to solve it. Now what is the first question he is asking? Calculate circuit current. Circuit current, how can I calculate? I is equal to V by R. No? Potential ERMS is already given. R value, how can I calculate? Chappan. I is equal to V by R. ERMS is already given. Total resistance of the circuit, how can I calculate? Z. Z value is equal to? XL, that's it. So therefore, ERMS divided by square root of, R means total impedance, no? Total impedance is R square plus, here XL is, XC is greater than XL, no? So I will write XC minus XL whole square. This is my resistance, the total impedance of the circuit. Now can you say what is total R value? Shall I rub this? Make a note up to here. Okay, see ma. So now how can I calculate R value, ma? R value is how much? Chappan. In this condition, R value is how much? Chappan raya. R1, R2, R3, they are connected in series only, no? So R1 plus R2 plus R3 will become total R value. They are connected in series connection. So total R is nothing but R1 plus R2 plus R3. So R1 value 10, R2 value 5, R3 value 15. So 15 plus 15, 30 ohms is my R value. Clear, no? And XC, XY, XL values already they are present. So therefore total I value is how much? ERMS 200 divided by square root of R square. R square is 30 square plus XC is 25, XL is 15 wholes. That's it. So calculate this value, that is the amount of current which can flow in this circuit. So current should be how much? 6.33 amperes. 6.33 amperes. That is my answer. Understood, Nama? Okay. Now, phase angle. Can you say how can I calculate phase angle? Chappan. Phase angle. Tan pi. Okay, ma? So see. So, idhar up cheste kashtam. Idhar up chesina kashtam. So second question is phase angle. Okay, see ma. This is called phase angle pi, no? Opposite side I know. So let us draw impedance diagram. What is the impedance diagram? So this is R. This is XC minus XL. And this is Z. And this is my pi value. I can write like this, no? So this is VL minus VC. VL minus VC launch I తీసేస్తే XC minus XL. And this is resistance, this is impedance. Clear, no? So XC minus XL I know, resistance also I know. So therefore you take tan pi. Okay. XC is how much? 25. XL is 15. So 25 minus 15 divided by, what is the total resistance? Total resistance is 30. Clear, no? So therefore, tan pi value is how much? 10 by 30, 1 by 3. Okay, ma? So therefore, I will write here. Therefore, pi value is how much? Pi value is tan inverse of 1 by 3. This is my phase angle. So tan inverse of 1 by 3 will be how much? Tan inverse of 1 by 3 will be 18.26. 18.26 minutes. Clear, no? So that is my second question. Now third one, circuit power factor. Okay, ma? Power factor, how can I calculate? Power factor formula? Chapandi. Memory power. అంటారు దాన్ని. ఇప్పటికే 30 సార్లు చేసిన కాస్ పై. సో కాస్ పై. సో కాస్ 18.26. ఓకేమా? ఆల్రెడీ పై వాల్యూ వీ హ్యావ్ క్యాల్కులేటెడ్, నో? సో కాస్ పై విల్ బి 0.949. 0.949. So power factor also we have calculated. Now what is the fourth one he is asking? Fourth one is power consumed. Okay? Power consumed. Power consumed, how can I calculate? How many formulae are there? So either I can use ER, IR, cos pi, or I can use IR square into R. Current we have already calculated, no? 6.33 whole square. Resistance is 30. Okay? So do this calculation, we will get the power consumed. So answer is 1201.4 watts. That's it. Okay? See, ma. So see this question. A circuit having a resistance of 4 ohms. So resistance of the circuit is 4 ohms, ma? And what is the inductance given? 0.5 Henry. And there is a variable capacitor in series, ma? So capacitance is variable. What is meant by variable? It can have any value. Its value changes according to the situation. Okay? So, and what is the supply voltage? ERMS is equals to 100 and the frequency is given as 50 Hertz. This is the question. Now the question is that, so this is what kind of circuit, ma? RLC circuit. Okay? So I want the required amount of capacitance to give resonance. So what is the first condition? Capacitance is how much? Such that circuit goes into resonance. Circuit goes into resonance. So what are the conditions of resonance, ma? Do you remember? No. That is the result. Condition of efficiency. Condition of resonance. VC is equals to VL. This is the condition of resonance, no? VC is equal to VL. Potential drop across capacitor, potential drop across inductor, if they are equal, then circuit enters into resonance. And when VC and VL are equal, definitely XC and XL also will be equal, no? So this is the condition of resonance. So what I want variable capacitance, and inductance is already given. So therefore XC value 1 by 2 pi FC, no? XL value 2 pi FL. From this I can calculate capacitance. No? Are able to understand, ma? Or directly you can use from resonating frequency also. Okay, ma? Just for your understanding, once again I have written. So therefore capacitance is how much? Capacitance is equals to 1 by 2 pi F multiplied by 2 pi FL. Clear, no, ma? So this is the capacitance. So therefore C is equals to 1 by 2 pi F whole square multiplied by L. So substitute all the values. So C is equals to 1 by 2 pi. What is the frequency? 50. 50 whole square multiplied by inductance is 0.5. So do this calculation, I will get the required amount of capacitance. That's it. Okay? So capacitance value 20.26 into 10 power minus 6. 20.26 into 10 power minus 6 farads. This is the capacitance. Okay, ma? So if this much of capacitance is present for these values, then circuit enters into resonance. Okay? That's it. Now see the next question. So voltage across inductance and capacitance. So V is equal to I into R, no ma? V is equal to I into R. If I know R value, if I know I value, then XC and XL already they are given, no? Are they given? L is given. Capacitance already I have calculated. Very easily I can calculate the voltage drop across the capacitor and inductors. But I value, how can I calculate? That is the question. I value, is it given? I value is not given. So how can I calculate? Current ఇవ్వలేదు కదా, మరి ఎలా? ఎనీబడి చెప్పండి. I value current flowing in the circuit, how can I calculate? P ఎవరు ఇచ్చినారా? Anybody? What is the property of resonance? Resonance లో మనం ఏం చదువుకున్నాం చెప్పండి. బాండ్ డిస్ప్లేస్మెంట్. కెమిస్ట్రీలో కాదు, ఫిజిక్స్లో. In resonance what we have studied? Seema, in resonance ఇంకా still what we have studied? Phase. అది అయిపోయింది ఆల్రెడీ. ఇంకా స్టిల్ ये मुक्का समझ में आया नहीं, मैं बोलता हूँ. In resonance we studied that only resistor consumes energy. ये पॉइंट చదువుకున్నాం కదా. बहुत जित में बोले सो वो नहीं. Okay. See, in resonance what happens is, in resonance only resistor consumes energy. Already we have studied, no? Only resistor consumes total energy or total potential. Okay ma? Total supply potential will be taken by whom? మీరు సప్లై చేసిన పొటెన్షియల్ అంతా ఎవరు తినేస్తారు? ఓన్లీ రెసిస్టర్. దట్ ఆల్రెడీ వీ హ్యావ్ స్టడీడ్. నో వాట్ ఈస్ ద సప్లై పొటెన్షియల్? 100. వాట్ ఈస్ ద రెసిస్టెన్స్? 4. సో దేర్ ఫర్ డైరెక్ట్లీ యూ కెన్ సే I is equal to V by R. సో I is equals to V is 100, resistance is 4, so 25 amperes of current will flow in the circuit. Okay ma? So in remaining circuits, out of this 100, clear ma? Some potential will be taken by capacitor and inductors also. But this is in resonance. In resonance, total 100 will be taken by resistor only. But it doesn't mean that other components don't have voltage. They too have voltage. But that is not the voltage given by supply. Their voltage is much greater than 100. Already we have studied Q factor lo em chadukunnam manamu. In Q factor we studied potential drop across resistor or inductor divided by potential drop across resistor. It means there is a potential drop across inductor and capacitor also, but that is not given by supply voltage. Supply voltage totally is consumed by resistor only. This point you should remember. Okay? Now see. So when I got current flowing in the circuit, right? Similar. So current already we have calculated. No, now he is asking us to find out voltage drop across inductance and capacitance. So VL is voltage drop across inductance, no ma? How can I calculate VL? I into XL. That's all, no? So I into XL formula 2 pi FL. Just substitute in this one. Current already we have calculated 25. 2 pi into frequency is 50. L value is 0.5. So do this calculation. That is the voltage drop across inductor. Clear? Next VC. VC is I into XC. That's all, no? So I into XC value 1 by 2 pi F into C. Clear, no ma? So current is how much? Current is 25 multiplied by 1 by 2 pi into frequency is 50. Capacitance already we have calculated, no? 20.26 into 10 power minus 6. So do this calculation. That is the value of potential across capacitor. Ante, very simple. So therefore what are the values we should get? 3927 volts. 3927 volts. Okay. See, if it is 3927, can you say what can be this value? Definitely they must be equal, no? Then only circuit will be in resonance. పిచ్చి పుల్కల మాదిరి ఇది చేసి మళ్ళీ దీన్ని కూడా చేసి మళ్ళీ అదే ఆన్సర్ వచ్చి అర్రే రెండు ఒకే ఆన్సర్ వచ్చినాయి కన్ఫ్యూజ్ అవ్వకుండా డైరెక్ట్లీ యూ కెన్ రైట్ 3927 volts. Because circuit is in resonance, no? What is the potential drop across inductor? Same potential will be across capacitor also. So this is our problem. So this is the end of topic called alternating currents.